Let's look at one where we don't have infinity showing up in the bounds. So this is the integral from 0 to pi over 2 of the opposite of the natural log of x. 0 and pi over 2 are not infinite, so the function must be the problem here. And if we think about what natural log looks like, it's like this. It does have a vertical asymptote. This is flipped upside down, so we're actually going like this, sort of a really rough picture. This crosses at E. Okay, so we're going from 0 to pi over 2. So we are integrating right up to that vertical asymptote. Let me think about this. E is a little less than 3. Pi over 2 is around a little bigger than 1.5. So we are stopping before we cross. Not that it would be a huge ordeal if we crossed. But we are stopping before we cross just to get the picture right. So we're looking for this infinitely tall, skinny piece of area. And we want to know, is it finite or is it infinite? Okay, so we want to remove the problem. So 0 is the problem. I'm going to replace it with an A. You choose your letter. It better not be X. That would be a bad thing. X already has a meaning. And then we're going to take the limit as A approaches 0. And notice we're only interested in A approaching 0 from the right. So we don't have to think about negative numbers, which is good because natural log's undefined. Okay, so we need an antiderivative of the natural log of x. And I think I might scratch work this one again so that I don't have to write the limit in every single step. I'm going to erase my picture. So if I want the integral, I'm going to move the minus out in front, natural log x. That's not trivial, but we can be clever and use parts. So if we're going to use parts, we're going to say that u is the natural log of x. So du is 1 over x dx. dv is dx, which means v is x. So we're introducing an extra x, but the derivative of natural log is much simpler than natural log itself to work with. So we're going to have this minus sign, and we're going to have a u times v, so an x ln x minus the integral of v du. So x times 1 over x dx, which is just 1. And the antiderivative of 1 is just x. So we get negative x ln x minus x, and then there would be a plus c. And I'm going to go ahead and distribute. So negative x ln x plus c. Okay, so back up here, I'm working on the limit as a approaches 0 from the right of negative x ln x plus x evaluated from a to pi over 2, which gives me a limit. Please do write the limit in these steps unless you're going off to do side work. Okay, so pi over 2, negative pi over 2 times the natural log of pi over 2 plus pi over 2 minus negative a ln a, so that's going to be plus a ln a minus a. Make sure that minus distributes through. So as a approaches 0, none of this stuff changes. We have a negative pi over 2 natural log pi over 2 plus pi over 2. As a goes to 0, a goes to 0. No big deal there. Here is an interesting one. We have a going to 0, but remember natural log has an asymptote at 0, so this is actually headed to negative infinity. And this is somewhere that L'Hopital's rule can be really helpful. So I'm going to scratch work again. According to L'Hopital's rule, if I have the limit as a approaches 0 of a ln a, if you have a 0 times infinity, you can rewrite that as a fraction and it will be a 0 over 0. So I'm going to do it like this. I'm going to leave the natural log of a on the top, And remember that multiplying is the same as dividing by the reciprocal, or vice versa is how we usually use it. Dividing by 1 over a is the same as multiplying by a. So now as a goes to 0, the top's going to negative infinity and the bottom's going to positive infinity, which means L'Hopital's rule does apply. And the derivative of the top is a 1 over a. The derivative of the bottom is a negative 1 over a squared, which simplifies. I'm going to use a tiny bit of cheater notation. I'm going to bracket this off to simplify. I can't even read my own thing. I think that's just an a. Yes. Simplifies to negative a squared over a, which is just a negative a. And then if we take the limit as a goes to 0, that's going to go to 0 as well. So in the end, it's plus 0 minus 0, or just negative pi over 2 natural log pi over 2 plus pi over 2. Okay, so a little bit of a messy one, and I did try and get a mix because I want you to remember your integration techniques again. So you will have some parts, and I think some partial fractions, and some subs, and I think even a trig sub or two in the mix. So watch for those and practice them. Thanks for watching.